So, oftentimes in chemistry, when we, in everyday life, oftentimes we get little powders or things that we're working with. They're hydrated. And hydrated means that each of the little bits of powder have water attached to them. What we're going to work with today in our lab is called Epsom salt. And it's just like a white salt. It's not very impressive. You probably soaked your feet in it. You ever heard of that? Epsom salt? It has other uses for that, but in modern day, like it's in bath bombs. You know the thing you throw in and your bath explodes. No, just kidding. But the things that you put in there and then you sit in the bathtub, it smells like lavender or whatever. There's usually Epsom salts in there too. And we're going to do a lab today with some Epsom salts, and I'm going to show you the formula. So if you go to you're going to be working on a left-hand page, but right now let's just do some notes and for people that may be home. When we look at Epsom salt, the formula for Epsom salt is this. Is there an L? No, there's no L. Here we go. Epsom salt. The formula for Epsom salt is magnesium sulfate, MgSO4, dot something H2O. You can, you don't have to right now. Just watch. Magnesium sulfate in the form of Epsom salt comes as a hydrate. A hydrate. And y'all know what being hydrated means, right? It means having enough water. We take these little bits of these little compounds and we attach water molecules to them previously before we put them in a package and send them to your house. Why do you think we might pre-attach water molecules to Epsom salt before we ship it to someone? That's inconvenient. Well, the reason that we would take some of these powders that are often shipped to people's houses and stuff, the reason we will go ahead and attach these little powders to tiny water molecules is to keep them from clumping up. Have you ever had a powder that you purchased and then you start to use it, or it's been in your cabinet for a long time and it's a bunch of clumps and you have to bust it apart, or sometimes it's no good? Something that's notorious for going bad like that is Kool-Aid. If you have powdered Kool-Aid that's been in a container for months in your house, you get it's just like a brick, just a chunk. That's because it's gotten moisture from the air and it's dissolved into the powder and it's all just gotten glued together with the moisture. So we hydrate things like Epsom salt before we ship them out. Well, we're going to do a lab today, and we are going to see what number goes here. We're going to see how many water molecules are attached to every magnesium sulfate. Does anyone have an idea how we might do that? By weighing? All right. Well, the gist of the lab is this. Here's the short-term part of the lab. You will take a container with some Epsom salt in it, and you'll figure out how much just the Epsom salt weighs. And I'll draw it in here as this blue powder. Okay? So it's just got a pile of Epsom salt in here. And then you're going to weigh that. All right? And of course, we're going to have to take out the weight of the container. And the container, in this case, is going to be one of these porcelain bowls, right? Right? So we're going to put some Epsom salt in one of these. Then, what you can do is get a Bunsen burner on this bad boy and just hit the flame to it. When you hit the flame to it, what should happen? What should happen to the water molecules? Yeah, the water molecules should evaporate and go away. So what we can do is we're going to calculate the percent mass, right, like we did in the last chapter, we're going to take the percent mass that was water. If you know how much the powder weighed before you heated it up, and then you reweigh it after you heat it up, and you see what percentage of the mass is gone, the percent mass that was missing was water, wasn't it? Does that make sense? So you'll be given in your lab, you'll be given the opportunity to weigh your powder, heat it up, then reweigh it. And I'll ask you if your powder was one of these three formulas. I will ask you if your powder, if you think it was magnesium sulfate dot 3H2O, which would be called magnesium sulfate trihydrate, or you could see if it was magnesium sulfate dot 7H2O, which would be called magnesium sulfate heptahydrate, or maybe it was magnesium sulfate dot 10H2O, which would be called magnesium sulfate, I guess, decahydrate. Does this make sense? So you can do some math with these in the end. You could look at this formula, add this up, and find out what percent of this is water. You could do the same with this. What percent of this formula is water? And then you could do this. What percent of this formula is water? Whichever one of these matches the powder that you heated up means this is the one that was the powder. Does this make sense? Yeah, and if anybody doesn't get it, or if you're watching this video at home, wait till we watch it on video, because we're about to do it. All right? Okay, so y'all know the weight before, and then we're going to put some of this in there. Put some of the magnesium sulfate in there. And now we can see the weight after. So now we know how much just the powder weighs. So we put a flame on it, and as the flame comes, the powder, you can see the water coming out of it. You can also hear the water coming out of it. So we're dehydrating the powder with the flame. That's right. So the total weight in the first place of everything was 112. Okay? And then the total weight in the end was 106.08. The plate weighed this much. So the plate originally, the Epsom salt originally only weighed 17.8, right? So the weight went down by 6.3 grams from there to there. So 6.3 out of the 17.8 total, that's the amount of water that was in there. Does that make sense?
Yes.
So, Zion, I'm going to use the numbers from your group, okay? So, here's how we figured out our math. Zion, how much did your just the bowl weigh?
94.58.
So just the bowl was 94.58, and then after you put the powder in it, how much did it weigh?
112.38.
112.38. So if you subtract the bowl from that weight, then you know you just have how much powder. What was the weight of your powder? 17.8 grams. Okay. Then they put a flame under there. Okay? And they got all the water to go away. And after that, they reweighed this thing. They reweighed the bowl and the powder. How much did it weigh the second time?
After the flame?
Yep.
11.5.
No. How much did the whole thing weigh?
Oh.
106.08.
What?
106.8. 08.
Oh, okay. So then the whole thing, after the water had gone out, it weighed 106.08. So it went down from 112 to 106. So there's about 6.3 grams of water. Is that what y'all got?
Yep.
So 6.3 grams of this was water. We know that the total weight of the powder when it had the water in it was 17.8 grams. So what percentage of this was water? 6.3 out of 17.8?
Oh, wait, no, we did that wrong. Okay. We did 6.
So you would say 6.3 out of 17.8. And they would say about 35% of theirs was water. Okay? Did anyone have one they dried longer and they got a higher percentage of theirs being water? What percentage of y'all's was water?
43.
All right, y'all got 43%. So y'all's was, you dried yours better. The flame was hotter, something, right? Okay, anybody else have a percentage higher than that? Let's go with their higher percentage. What'd you get, Sophia?
46.
46? Okay, I like that, 46%. All right, let's see. So their number was 46% water. Now, we would have a choice here. Was the formula MgSO4.3H2O, MgSO4.7H2O, or MgSO4.10H2O? Let's add this one up. MgSO4, just stick with me because I'm going to go quick. If you're on video, you can rewind it. This weighs 24 plus 32 plus 64 plus 3 times 3 waters is 54, because this is 2 and 16, that's 18. I know I'm going fast, but you would get these numbers with the calculator. So the total weight of this one is 24 plus 32 plus 64. 24 plus 96 plus 54. That's 174, right? It's 174. And out of that, 54 of the grams were water. So 54 out of 174 will mean that that one was 31% water. So the group that had 46% will be like, that's probably not what ours was. Let's try this one right here. Magnesium. If you watch, this is not confusing. Some of you are making faces at me. Ready? 24 plus 32 plus 64, and then 7 times 18 is 126 plus 126. Let's add these up. 24 plus 32 plus 64 plus 126 is a total of 246. And out of that 246, 126 was water. 126 divided by 246 is 51%. That's much closer. Do y'all agree? So if Sophia's group got 46%, then they would say this was the formula. That powder was actually MgSO4.7H2O. Does that make sense to everybody? And this one, the percentage would be even higher than 50%. How many of y'all had a number closer to 31%? Right, several groups. In reality, the number is actually this one. The formula I gave you is actually .7H2O. That's the actual one. So let me ask you one quick question. Groups that got a lower percentage, what was the problem? What did you need to do more? Yeah, it just needed to stay on the flame longer till more water left. And the only reason you got this low number is I made you turn the flame off because we were breaking the dishes and we're also running out of time. Does that make sense? Do you understand that if you'd have let the powder sit there for an hour, right, then you would have gotten 51% of the powder's weight would have disappeared? Does this make sense? All right. That's it. That's how you can calculate which hydrate you have.